Hello and welcome to the Brightics AI Accelerator tutorial series. This is episode number 6, an overview of our TensorFlow framework.
I'm going to explain two notebooks. One is the notebook for a typical 101 example of training and prediction in AI Accelerator, and the other is for batch inferences. So let's go to the first notebook. So in this notebook, we'll be seeing how to train synchronous distributed deep learning model using AI Accelerator. And here the problem that we are going to take is basically trying to figure even an odd number in CFAR10 data. So essentially you have 0 to 9. You want to see whether the digit is even or odd. A slight variant of many of these examples of CFAR10 data. So just for the change. So we try to import all the packages. The packages are named as brain, which basically contains the API to access our product, and this just a constant for iterations for the sake of this experiment. The AI accelerator is heavily inspired from TensorFlow estimator. So we'd be having a model function and an input function, and in the input function you can do whatever you want to do with the data, which is essentially pre-process the data, do some transformations that you want, extract the data from some online resource, but at the end of the day, we want the data to be in a TensorFlow dataset object. And in the model function, we want it to be in the estimator spec object, and so that the training is very similar to the signature is very similar to how you do estimator style of training in TensorFlow. So here we are trying to extract the CFAR10 data, we are trying to convert them to TF records, and the reason why we chose like order even is basically to just showcase that we are doing some pre-processing in here, basically crop the image or randomly flip and resize, and also we adjust the labels. If you see it, like because CFAR is from 0 to 9, we try to adjust it whether it's even or odd. That's our label for this particular problem. So just to demonstrate these capabilities in the model function, so we have this. So even in the model function, we have something called mode and the params. So basically params are all the hyperparameters that you want, and mode, it essentially, if you want to do some kind of an pre-processing or transformation for training, then you can use the mode, just like how you basically use the TF estimator mode, right? So it's a very simple. So you can essentially use TF estimator mode and then try to define your pieces accordingly. And so with that, we also define a model function. Model function, again, this model function is very much similar to TF estimator's model function, because we do run these codes on in a distributed fashion, but like through the TF estimator style. So which is one of the distributed styles of running in TensorFlow. So you define the model function. The model function can vary from a couple of layers to resonate, and based on the mode you can also define whatever you want to. Like for example, if the mode is predict, then you can define the softmax and probabilities, just like how you do it in a TF estimator code. If it's trained, then you basically want some learning rate decays to be defined, and optimizer, like we use momentum, basically try to minimize them, and then return an estimator spec for training. So each of these mode has a separate estimator specs, right? Just like, again, very simple to writing a TensorFlow estimator code. Until now, you can just retain your TensorFlow estimator style of code, and it would still it's all fine, right? From now on is where the AI accelerator utilities come into picture. So first, we try to define an estimator in here. We, of course, ask what kind of an name that you want, and also here, when you basically define what type of estimator you want. In this case, it's a classification task. So we provide, and then we provide a model function. So we just want to make sure that, we have got all the requirements for the model function, right? Like returning of estimator spec and, stuff like that. So once you define the estimator and then you create an estimator, so you define hyperparameters. So uh, in this iterations and batch sizes are like they are mandatory. I mean, no experiment can run without them. I mean, they're the basic. But you can also define a set of hyperparameters like these constants in here, and it should still work fine, like as a dict, and yeah, it would still work fine. So, and not just that, you can also define a hyperparameter space wherein you can provide a list of hyperparameters for each of these hyperparams, and we will still be running like a job for each of this hyperparameter space. So once you define the hyperparameters, you have run config, which predominantly takes care of your hardware requirements, like how many containers do you need in this distributed experiment. Like, do you want to use the GPU? I mean, right now we support synchronous training, so sync equal to true, stuffs like that. And we need a name for your experiment, and then you just put in necessary you just put all these pieces under one common boundary, and that's called experiment. So just a little bit about how this experiment uh, works is, in AI Accelerator, experiment is the topmost layer, and each experiment has multiple can have multiple jobs. I mean, in this case, there's going to be only one job, but they can have multiple jobs, and especially and each of these jobs will yield a model. And so experiment on an abstract level has many utility functions that can be used, and from which you can basically get different functionalities. So I mean, especially if you are going to provide a hyperparameter space, and then if you're going to run an experiment dot run, so there will be like multiple jobs inside one experiment. I mean, very similar to how data scientists work, is that there's an experiment that you want to solve, that you want to try out, and there are multiple different ways, different hyperparameters or different types of data set that that you need. Then mm, you just change the input function, and then everything remains the same, and you can run multiple jobs in under one experiment. And so we essentially run this, and once you run, all the internals is taken care of, like the distributed type of running, and how we scale. Also, you can provide any hooks if you need to I mean, and we should be able to accommodate that too. um, like especially hooks are required when you really want like any kind of summaries on a worker level, and we can have that too. So all the internals about how we spin up the workers, and who's going to be the chief, and how does these communicate. Like, we of course leverage the distributed TensorFlow, but on top of that we also manage them using we also manage them internally, and then that's abstracted to the user. And so if you actually yeah so as I was saying here before, there were a lot of utility functions. For example, you can just say, in this case, you just say experiment.get single job, because there's only one job mapped to this experiment. And then you can have something like wait until finish, and you can basically get model metrics from each of these experiment and jobs. You can also get the best model. There are many utility functions, and you would be basically seeing them. Okay, now that we have started the experiment, we really want to see how they're doing. So we have a dashboard here where you can actually check out each of these logs and how they have run. And so this particular experiment just started running, and for each of these, we also have a log, and we have a TensorFlow. For example, if you can actually check out the log, as to see how they are running. Let's say that you see some other error, which TensorFlow is usually very notorious to do, like, and you want to have more control. So you can also see the container logs and then see what all it's spitting out. And we try to be transparent and then see, let's say that somewhere down the lane, usually TensorFlow errors is just bad. They just fail at some random point, and you have no idea how to traverse it back. So we also split the container log so that you have complete visibility as to where it failed. We also have Tensorboard, where you can see how your training is progresses. Like, this is the typical TensorFlow style of seeing uh, where your how much your training has progressed. We have recorded loss, global step, and accuracy as the summaries. But if you have any other summaries, you can of course add them in your model function, and you should be able to see them just like any other TensorFlow program. The user prefers our AI accelerator, and then he hands off the data. So then we run the inference job given the set of images uh, that has been specified in the input function. Then we basically run an inference job wherein we specify the input function and the output function, yeah, and also the model function. How do you want your inference job to be run? Like, you want a GPU, or you can run a CPU job, like however you want to do that. So there you see the inference job is completed, and there was a set of 1,000 images that had to be predicted, and then we predicted them as like one single batch. So that's pretty much the end of the video for inference. Thank you.